Okay, so for this video, we are going to learn a little bit about momentum. Okay, momentum is 1.6 under general physics. Okay, so first we are going to learn about the definition of momentum. So the definition of momentum is actually based on its formula, which is P equals to M times V. So P is momentum, okay, P is momentum, M is mass, and V is velocity. So basically, mass and velocity, when you multiply them together, you get momentum. So momentum, the definition is the product of mass and velocity. Okay, so let's say we have an object. This object is 2 kg and it is moving at 10 meter per second. Okay, so from here, if we were to calculate the momentum of this object, we have to use the formula P equals to M times V. So momentum is mass times velocity, where the mass is 2 kg and then your velocity is 10. So when you multiply them together, you will get 20. And the unit is kg meter per second. Why? Because M is mass, so the unit is kg. V is speed or velocity, so the unit is meter per second, which is why your final answer will be 20 kg meter per second. Take note that momentum is a vector quantity, so it means that you need to take into consideration both the magnitude, okay, and also the direction. Okay, later when doing question, you will see there's a difference in terms of direction when doing momentum. Okay, next. Let's do question number 4. So an object is moving with velocity 4 meter per second. So the V is 4. If the momentum is 20 kg meter per second, so you already get the value of momentum is 20. So calculate its mass. So we want to find the mass. So now we know that the formula is P equals to mv. So if your momentum is 20, your mass is the one that we are trying to find, and then your V is 4. So M is 20 divided by 4. So M is 5. Remember the unit? kg. So this is how you calculate information from the formula for momentum. Okay, so now we are going to look at principle of conservation of momentum. Understand that the principle of conservation of momentum is basically total momentum before is equal to total momentum after. Okay, so the definition for principle of conservation of momentum is total momentum before collision is equal to the total momentum after collision if no external forces is acting on it. So the idea is you know that the total momentum before is equal to total momentum after. So let's say we have two objects, A and B. So ball A, the mass is 2 kg, which is M. And then we know that it is moving at 10 meter per second. So that is the information we have for ball A. And then for B, it is at rest. So we know that the V is 0, but the mass, it is bigger, which is 5 kg. Okay, so now calculate the momentum. Remember, we learned that momentum, the formula is M times V. So M is 2, V is 10. So we know that the momentum for A is actually 20 kg meter per second. So that is the momentum for A. And now, momentum for B is 5 times 0. So we know that the momentum is 0 kg meter per second. Okay, so from here, we add them together to get the total momentum. So 20 plus 0, we get 20 kg meter per second. Okay, so this is the total momentum of the two balls before before collision. Okay, so after collision, basically ball A has hit ball B. So ball B is now moving. Okay, so you have to understand that for principle of conservation of momentum, the total momentum before is equal to the total momentum after. So we know that the momentum before is 20, So the total momentum after is also 20 kg meter per second. Doesn't matter whether A is slowing down or B is moving faster. Okay, as long as there is a principle of conservation of momentum, we know that the total before is equal to the total after. So before is 20, so after is also 20. So let's say because A has hit ball B, now it is moving slower compared to initial speed. So now let's say it is now 5 meter per second. So calculate the momentum of ball A. So 2 times 5 we get 10. Okay, so 10 meter per second. So the total is 20. So PB or momentum B we know is 10. Why? Because 10 from A plus 10 from B is 20 kg meter per second. Okay. So if they ask you what is the speed of B, we can use the formula P equals to mv. Okay. And then P is 10. M is 5. So V is 2. So we know that V is 2 meter per second. So this is the concept of total momentum before equal to total momentum after because of principle of conservation of momentum. Okay, now this is a rocket. So the rocket initially it is not moving, and also the fuel inside the rocket is also not moving. So now because they are not moving, according to the formula of momentum P equals to mv, if the V is 0, doesn't matter what's the mass, the momentum is also 0. So we know that momentum of A is 0, momentum of B is also 0. So our total momentum now is 0. Okay, now as we can see, when there's a combustion inside the rocket, it will produce exhaust. So when it produces exhaust, it will move upwards. Okay, why? Because there's a downward momentum. Let's say the downward momentum is 10,000 kg meter per second. We have to come back to the principle of conservation of momentum where total momentum before is equal to total momentum after. Okay, so we know that before is 0. So after also has to be 0. So we already have the downward momentum 10,000 kg meter per second. Okay, so we know that this is 10,000 kg meter per second. So the total we have to add with the upward momentum, we still get 0. Why? Because before is equal to after. Okay, so if before is 0, after is also 0. So we can do 10,000 plus momentum upwards. So from here, we get that the momentum upwards is also 10,000 kg meter per second. But it is negative. Why it is negative? Because it is in opposite direction. So in conservation of momentum, okay, for explosion, in this case, for the rocket, okay, we have both upwards and downwards momentum at the same magnitude but opposite direction. So this is how the explosion, okay, and also the rocket uses the principle of conservation of momentum. Okay, let's try and do this question. Question number 2. Okay, so first, an orange ball hits a green ball. Then they both move attached together in the same direction. Calculate speed of green ball after the collision. Okay, as you can see here, they are attached together after the collision. However, the concept or principle of conservation of momentum still applies here. So what you can do is calculate the total of momentum before. So how do you do that? The first one is use the formula P equals to M times V. So M is 2 times V, it is 8. So you get 8 times 2, you get 16. So 16 is actually the momentum of the orange ball. Okay, now you use the same formula to calculate the momentum of the green ball. However, as you can see here, the speed is 0. So you know that the momentum is also 0. So when you add them together, the total momentum before the collision is actually 16 kg meter per second. So we know that the total momentum before the collision is 16. Okay, so now we know that based on the principle of conservation of momentum, the total of momentum before is equal to after. So we know that momentum before is equal to momentum after. So we already know that the momentum before is 16. So we know that the momentum after is also 16. So for momentum after, we use the same formula P equals to mv. So momentum, the mass is now 2 plus 1 because they are moving together. So we can treat them as one object. So now the mass is 3. Okay, so now you are trying to find V. So we know that 16 is now 3V because before is equal to after. So 16 divided by 3, and then you get 5.33 meter per second. So this is your velocity. So calculate the speed of green ball after the collision. The answer is 5.33 meter per second because they are moving together. So knowing this V is actually knowing the speed of the green ball. So this is the final answer. Let's try do another question. Here, this is actually from the IGCSE question. Okay, past paper. So, a ball of mass 2 kg is traveling at speed 12 meter per second. And then it moves towards this 3 kg which is at rest. So, the ball hits the object and then sticks to it. So, basically they will be moving together after the collision. So, the question is calculate the total momentum after collision and speed of both objects. So basically we're trying to find both after the collision. The first one we want to find the total momentum. The second one we want to find the speed after the collision. Okay, so total momentum after collision is equal to before collision. Since we cannot actually calculate after the collision, we can calculate before the collision. Okay, so how do you calculate the momentum before the collision? P equals to mv, and then this one P equals to mv. So the mass here is 2, the V here is 12. So you calculate them together, you get 24 kg meter per second. So for this one, 3 times 0. So you get 0. Total momentum is 24 plus 0, which is 24 kg meter per second. So this is the total momentum before. But since, according to principle of conservation of momentum, the total before is equal to total after, we now get the total momentum after collision is the same, which is also 24 kg meter per second. So this is the answer for the first part. Okay, now the question is asking about the speed. Okay, so we know that the momentum before is equal to after. So now, after the collision, we know that they will stick together and moving together with same speed. So this one is 2 kg, this one is 3 kg. So the total mass here is 5 kg. According to formula of momentum P equals to mv, the momentum we know is 24. How do we know the momentum is 24? Because before collision is the same value as after the collision. So before is 24, now after is also 24 kg meter per second. So the mass is 5 and we're trying to find V. So V is 24 divided by 5. So you calculate and then you get 4.8 meter per second. So this is the speed of both objects, 4.8 meter per second.